much. Good afternoon. I'm sorry that I will be the one take you to the underground now. So another geomorphological feature a little bit hidden from our eyes from the surface. So I will be presenting Škocjan caves in the classical karst, and I will explain the term classical karst shortly. So all the credits for this successful application of our geosites goes to my co-authors, Nadia Zupanhajna and Andrej Mihevc from the Karst Research Institute in Slovenia. Yes, we have a special institute in Slovenia devoted to karst research, and Borut Peric from the Škocjan Caves Park. And Nadia Zupanhajna, let me tell you, she was just recently appointed president of the International Union of Speleology. So, just to take you where we are. So this is the small piece of land called Slovenia. And in the southwestern part, we have a region that is called Karst. And the region expands also to the east, to the southeast, to Italy, where they call it Karso. But the German word for this region is Karst. So there is where the term karst originates. So it originates in our area of indigenous Kras. So that's why we call it the classical karst, this part in Slovenia. So, and the Škocjan caves are in this rim of the classical karst. To the geological content. So the main structure is basically quite a relatively large anticline with an axis trending northwest-southeast. And it's composed mainly of the well-bedded, thick-bedded, lower Cretaceous to upper Cretaceous shallow marine limestone. And upwards, they go to especially the upper Cretaceous limestone, they are full of rudists also, like you have it here in Zumaya. So, and they trend upwards into the Paleocene and Eocene foraminiferal limestone still. So this is the core of the anticline, and the whole anticline is actually surrounded, and the anticline calls the elevated surface that we call a karst plateau. So the karst plateau is surrounded by the impermeable flysch rocks. So the main interest in karst development is actually in this contact with impermeable flysch to the permeable limestones. So if we look into the details to this part, we can see even in the geological map the river Reka that runs from the impermeable flysch rocks, and almost immediately it touches limestone. It sinks underground in an area that are called Škocjan caves, which I'll be presenting now. So the best image I got for like a sketch image of the river Reka actually forming the Škocjan caves. It was one of the interpretative panels in the Škocjan caves part, which shows you the river Reka runs from the impermeable flysch rocks, sinks into the Škocjan caves. So these are the Škocjan caves. But Škocjan caves are mainly like 6 kilometers long, but the river Reka extends its flow underground, all the way underground, and actually flows out in Italy with the name of Timavo, very close to Trieste. So the whole part of the river Reka, of Timavo system, is mainly underground. So this is one of the sketches that you would find in the textbook of the karstic surface, so surface and underground geomorphological features, and you will be it will be easy for you to recognize actually that this model originates by Nadia Zupanhajna. It originates in the Škocjan caves system. So all these features we have developed in this small area with typical these ponors, like we call it sinking of the river. So we have the solution dolines and the collapse dolines. We have the underground cave system very well developed here. So before I take you with some photos to the Škocjan caves that you will see how they are developed, just I want to remind you that this is the part that I'm showing to tourists, that this is the touristic part of the cave where you can actually walk. This is a touristic way, but it is actually not even a half of the Škocjan caves whole system, because the system, as I told you, is more or less 6 kilometers long, and some of the nicest features, unfortunately, are still hidden for touristic visits. There are now efforts to open more of this part of the caves to see also one of the largest chambers, underground chambers in the world, or at least in Europe. Yeah, and the system of the channels, of the passages, is very much related to the bedding of the limestones and also tectonic features, and this can be very nicely seen in the cave. So it has a geological importance to explain how the cave develops, really. Just a few numbers also, although I think dimensions are not so much scientifically important, but when you enter the Martel chamber, so this is what is unfortunately still hidden, you will be wow. So it's really amazing. It takes your breath how big this chamber really is. You can see it, 2.2 million cubic meters of volume. And it's one of the largest underground chambers in Europe. But this table is actually more to show you the diversity of the geomorphological features that are exposed here. So you can see underground canyon of the river Reka. You can see these very large chambers. You can see rimstone pools, natural bridges, like natural windows, waterfalls and rapids, and collapse dolines also. So this is how it all starts. So I told you from the flysch rocks, the river Reka flows into the Škocjan caves with a very nice large ponor, how the sinkhole also is called. So we are just here now in my sketch, and with the next photo. I show you this, where you can actually see the river that runs underground, but you can see it from the top of these large collapse dolines. So we call it the little or the small collapse doline, and this one is the big one. And in pioneering karstic research, this doline, the term doline, which originates from the how the local people call these two collapses of the Škocjan caves, they were referring to these two dolines. So the term collapse doline again originates here in this part of the work. So now we enter the main part of the Škocjan caves, the underground part, the nicest part, with the river Reka, which is of torrential character. So in times of the floods or hard rain, heavy rain, sometimes the river rises almost to this bridge. So like 45 meters high, the river rises in this occasion. So we are now here in this murmuring cave, how they call it. We have also very nicely developed speleothems there, not only stalagmites and stalactites, also the rimstone pools. And this is one of the bridges that you pass when you go touristically to these caves. It's 47 meters above the bottom of the valley. Okay, to the scientific tradition, I must say that this site is almost as much as, or it can be as much valuable in the historically as it is for its geomorphological features, because in the 19th century, these geosites in the heart of the classical karst, so the whole area actually contributed to the emergence and the development of karstology, speleology, and speleobiology as scientific disciplines. So this is one of the first very detailed plan of the Škocjan caves. It's also in the profile and also in the aerial view. And you can see that the first passes here were, this is from the 1819th, the first passes are now already covered thickly by speleothems. So you can see the fences and this covered already. And it was due to the distinctive relief forms, local terms for karst phenomena, and karst, the word karst itself, enter the international scientific terminology here. These are two examples. One is from one of the textbook, and one is from Larousse Dictionary in France. So you can see all these circles. Terms are from Slovenian language introduced to the international terminology, like polje, dolin, ponor already, I told you, uvala also. So the main arguments for the IUGS recognition are the Škocjan caves with their innumerable remarkable speleological, hydrological, and morphological karst features are unique in their appearance and in their size. They are one of the most spectacular examples of contact karst formed by a torrential sinking river at the contact of impermeable flysch and permeable limestones. And for the textbook examples of sinkhole, natural bridges, gorges, potholes, collapsed dolines, abysses and underground canyons, springs and passages covered with flowstone deposits give this small area of the world significance in the study of karst features and processes. Due to their geological and aesthetic importance, they have already been recognized in several lists or by several different disciplines like UNESCO. It is on the UNESCO World Heritage list already since 1986, and in 1999 it has entered also the Ramsar list as the first underground wetland. And of course, for this peculiar geomorphological type that is underground, very complex environment, it is also the important natural habitat for comprising highly specialized and often endemic cave animals. And one of those that we are quite proud of is this European cave salamander, or an Olm, what is also called in German language. We call it a human fish because of the pale skin. And it's really like a symbol also of a Slovenian karst. And with this, I would like to thank you. Hvala lepa for your listening.